Hello everyone. So today we're going to present to you our project, which is about a self-stabilizing lever drone, supervised by our professor, Dr. Rashid Lol. Next slide, please. So these are the main points of our discussion or our project. The first one will be about the concept and or the objective of the project, and then we're going to move on to the design or the hardware. After that, we're going to see the code and the assembly and the drawing as well. And finally, we're going to have a motion analysis and the conclusion in the end. So to start it off, we have a problem here. The issue is the access to certain areas may be restricted or hard to reach. And this can be due to altitude, distance, or difficult routes. Therefore, we need an efficient way to provide an easy and reliable access. So could this project that we worked on solve this problem potentially? So the mechanism used in modern drones can provide a good solution to provide access to restricted areas without the need to install new access methods, which we'll see, the process of making it, etc., through the following slides, which gives us a general idea about the concept. So a drone is a vehicle capable of flight remotely by humans or autonomously using aerodynamic forces like stabilization, steering, etc. That was our initial project, but we decided to make it a lever drone, which uses motors to provide thrust and create equilibrium. Hence the self-calibrating, hence the self-calibration property of the drone. So now we're going to see how it works. So the lever drone that we use has an Arduino with an MPU 6050, which consists of multiple sensors, including a gyroscope. The sensors are able to detect when the drone is tilted, which allows for the calculations of the necessary thrust to create equilibrium. We also have the Zigbee protocol, which is a wireless protocol that sends signals to the drone in order to control it. Next slide, please. So these are the materials we use for the hardware prototype. We have the brushless motors, the ESCs, the battery, the propellers, a fixed frame, the connecting wires, the Arduino Nano, and finally the MPU sensor board. So as you can see here, this is the digital design that we've made through SolidWorks. And then we're going to move on to the hardware parts in the next slide, please. So yeah, here is an idea of how it's supposed to look like. So as you can see here, we have a fixed frame with the two propellers, the Arduino, etc. And we also have some of the components in the next slide. So here we go. These are the sensors and the modules, and I will leave you with our teammate Abdurrahman, who will explain further how the process goes.
So as you can see, we generated the exploded view. As you can see, here are all the components we have. So the brushless motors, the 30 ampere ESCs, the LiPo battery, the clockwise and counterclockwise propellers, the Arduino Nano, and the MPU 6050. So this is the main hardware or the main prototype that we had in mind. And next, we generated a drawing of the model that will give us the dimensions to know how it's to know like the dimensions of the parts that we want to print, the size of the parts, etc., and it would give us a better idea of how it should look like. We also have the bill of materials. It contains all of the parts that we use to construct the design, as you can see in this slide. So next is the code. So the code here is, since we're using the Since we're using the MPU 6050, we're using the I2C protocol to communicate. So most of the transmission is using binary. So as you can see, we begin the transmission, talking with the MPU. We set some properties such as the power management. We send 0 to it to wake up the device or to power it on in transmission. Then we move to the gyroscope. We set it to full scale. And we also do the same thing for the accelerometer. We set the scaling for the accelerometer as well. After that, we have two functions: record accelerometer registers and gyroscope. So basically the data from the gyroscope and the accelerometer are recorded in memory. So what we do is we jump to that part of the memory, and we wait until the data is available. Hence the while wire.available is less than 6. So as long as it's less than 6, so no real data is available. But as soon as we have data in the received by the wire protocol, we are going to read the first 2 bytes, which are the x-axis, the next 2 bytes y-axis, and the last 2 bytes are the z-axis. We do the same thing for the gyroscope. As you can see, the code is almost the same, but the only thing that's changed is the place where we request the data from, as you can see. So this is the data that's generated by the sensor. So as you can see, we have the gyroscope, the X, Y, Z, as we said, and we have the accelerometer. Of course, the MPU 6050 also has more sensors such as temperature sensors, but those are not relevant to the current scope of the project. Hence, they were not included in the code. So now I will give the floor to Iman to talk about the motion analysis.
Thank you, Abdurrahman. So we have used the motion study we learned in class to give an idea on how the drone work. We have taken it as we've take um, like the part as separate entity from the rest of the assembly to give you a clear view of how the blade is supposed to move. Um, Next slide, please. Also, we provided um, here are the screenshot of the process of working um, on the motion analysis. Okay, next slide. Yes, yeah, and then after the motion study, we will conclude that first the objective of the project is build a convenient way to navigate to area that may be unreachable in the easiest way possible. To achieve this goal, we used what we learned in this class to create SolidWorks models and simulations to create a virtual prototype of the end product. Also, the drone has many uses, including but not limited to construction, firefighting, marketing, and transportation. And yeah, this is the end, and this is our team, Abdurrahman, Aya, and me. We've had fun working on this project and building everything. Thank you so much, Professor, for giving us the chance and teaching us all this stuff about SolidWorks. That helped us a lot in our projects. As I said, we had a lot of fun working on this and doing it. And I will let you in the next slide with a wonderful view taken by a drone. Um, it's a video, actually. Yes, here we are. And yeah, this is the end. Thank you so much.